Okay, so in this video I'm going to have a look at what's called the general term or the nth term of a linear sequence. Now I'm going to take this particular sequence of numbers here, 4, 7, 10 and 13. Now this goes on forever, and if we look at it we can see that what we're really doing here is we're really just adding 3 each time. So 4 plus 3 will give me 7, 7 plus 3 will give me 10, and 10 plus 3 will give me 13. Now this plus 3 here, there are a few different names for it, but usually it's called the common difference. The common difference. Sometimes it's called the first change. Oops. Sometimes it's called the first change, C-H-A-N-G-E, and sometimes it's called the first difference. So a few different names for the same thing, but it's basically what you have to add to each term to get the next term. Now also I should stress here that each term here has a name as well. Like for example, this number here is called term number 1. So we would write it like that, T1. This number here is called term number 2, so we would write it like that. This is T3 and this is T4. And this keeps going on forever until eventually we end up at what's called Tn, if you like. So Tn stands for any particular term number. So Tn here would be the final term, if you like, in this sequence. Although it goes on forever, really, it goes on into infinity. But we have term number 1, term 2, term 3, term 4, all the way up to term n. So what we want to do is we can see here very easily that term 5 would be 16 and term 6 would be 19. So it's very easy to do here. The next term or the one after that, and so on. But if we were asked to find, say, the 50th term or the 100th term or the millionth term, it's going to take us a while to do that. We have to keep on adding 3 a million times or 100 times or 150 times or whatever it is. So what we want to do is find a formula that will allow us to find any particular term. And that formula is called the general term or the nth term. So let's see how we do that. So the way you would normally start these is you would write down Tn. We want to find out what any particular term is. So we start with Tn and we would write down equals then, and we look at this thing here, the plus 3 here, with the common difference, the first change or the first difference, and we just simply write down 3 times n. So what I'm saying now is that my formula for this particular sequence of numbers here is Tn is equal to 3n. So any particular number in this sequence can be found by just simply multiplying 3 by the value of n here. So let's see, does that work? Usually it doesn't work initially, we have to adjust it slightly. So let's see what happens if we do use this particular formula. So let's take, for example, T1 here. We know that term number 1 here is 4. Okay, term number 1 is 4. So let's see, does our formula, if we use this formula, will that give us 4? Well, let's see. T1, we want to find T1. Tn is 3 times n. We've changed the n here to a 1. So change this n here to a 1. So in other words, we're saying that T1 will be 3 times 1. 3 times 1 is 3. So what I'm saying here, if I use this particular formula here, T1 will be 3. But we know that T1 is not 3, T1 is 4. So what I can see here is that really what I have to do is add 1 to 3, and that will give me 4. So let's do that. So I'm going to say my new formula now is 3n plus 1. 3n plus 1. It's not Tn is equal to 3n, but it's Tn is equal to 3n plus 1. So let's see, does that work? Well, we know it works for the first one here. Let's see, does it work for, we'll do 2 or 3, we'll do 2 of these anyway and see what happens. So let's take the second one here, T2. We know that T2 is 7. So let's see, do we get 7 if we use this formula now? So T2, sorry, I just put this in again. That's 1 in there. Now let's see, T2 will give me 3 times. Now remember, I've changed the n here to a 2, so I changed this n here to a 2. So I'm going to put 2 in here, plus 1. If I do that, I get 3 times 2, which is 6, plus 1 will give me 7. Now is T2 7? Yes, it is. T2 is 7, so it appears to work. I'll just do one more and see, just to double check. Let's see. I'll do let's say T4 here. Well, T4, using this formula here, T4, I've changed the n to a 4, so that means I'm going to multiply 3 by 4 and add 1. Well, 3 4s will give me 12, plus 1 will give me 13. Is T4 13? Yes, it is. So this here is the formula that I can use to find any particular term in this sequence of numbers here. So if I want, for example, say the 50th term, rather than adding 3, adding 3, adding 3, adding 3, and so on until I get to 50th term, all I need to do is do T50. That's 3 times, now I've changed the n to 50, so I changed this n to 50, so it's 3 times 50 plus 1. That'll give me 3 times 50 is 150, plus 1 is 151. So my 50th term will in fact be 151. So somewhere up along here I will have T50, and that number there will be 151. Okay, so that's generally what you do. Okay, so let's do another one, and that'll be it then. So let's take a different sequence of numbers. So this time I'm going to take the sequence of numbers. Let's see, we'll go down this time instead of up. So let's take 7, 2, minus 3, and minus 8. Okay, so again, this is T1, this is T2, this is T3, this is T4, and so on. And that keeps going on till I get to Tn, any particular term really. So it goes on into infinity really. So let's start again. Let's look at our common difference first of all. What is D here? What's our first change? Well, if I go from 7 to 2, I need to subtract 5. If I go from 2 to minus 3, again I'm subtracting 5. If I go from minus 3 to minus 8, subtract 5. So my common difference here, my first difference here is minus 5. By the way, I should say here as well, there are some symbols here that I didn't mention earlier. T1 here is 7. It's usually given the symbol A. So A is the first letter of the alphabet, if you like. So it's the first number in the sequence. A is 7. And my common difference here, minus 5, is usually given the symbol D as well, D for difference. So D in this case is minus 5. So anyway, let's do our general term, or our nth term. So again, we start with Tn. We want to know what Tn is, any particular term rather. So Tn is going to be, now, how did we start the other one? Well, we took what the first change, the common difference here, and we just wrote it down, minus 5. We multiplied it by n. Now this is my formula. This is the formula I'm going to use, but I'm going to check it first and see, do I need to adjust it to make it work? So let's see what happens. Let's take T1, for example. Okay, so T1. Now, T1 is, I've changed the n to a 1, so change this n here to a 1. So that's minus 5 times 1. That will give me, minus 5 times 1 is minus 5. So I'm saying, using this formula here, T1 is minus 5. But if I look here, T1 is not minus 5. T1 is actually 7. So I need to add something or subtract something. I need to do something to this minus 5 to turn it into 7. Well, what I can see is that to go from minus 5 to 7, what I need to do, in fact, is add 12. So minus 5, in other words, minus 5 plus 12 will give me 7. So that should work. So I'm going to adjust my formula by adding 12. Okay, so now I'm saying this is my new formula. This is my nth term. This is my general term for this particular sequence of numbers. So let's see, does it work? Let's take T2 anyway. We'll try T2. So T2 is equal to minus 5 times, now change the n to a 2, so change the n to a 2 here, plus 12. If I do that, I get minus 5 times 2 is minus 10 plus 12. That will give me, minus 10 plus 12 will give me 2. T2, I'm saying using this formula, is 2. And we can see here that T2 is in fact 2. Let's try another one just to be sure. Let's try T4. What happens if I put 4 in here instead of n? Well, I get minus 5 times 4 plus 12. In this case, minus 5 times 4, that will give me minus 20 plus 12. If I do that, minus 20 plus 12 will give me minus 8. Now, is T4 minus 8? Yes, it is. Okay, so this formula here works. This is now my general term, or my nth term, or my formula that will work for this particular sequence of numbers here. So if, for example, again, I want to find, I don't know, let's say T40. I want to find what the 40th term is in this particular sequence of numbers. So if I keep subtracting 5, subtract 5 from 7, subtract 5 from 2, subtract 5 from minus 3, and so on and so on. If I do that 40 times, what number will I end up with? So I'm looking for T40 here somewhere. So let's see what happens if I do that. Well, again, I've changed the n to a 40. So that will give me minus 5 times 40. And I've got to add 12. Well, minus 5 times 40 is, that will give me minus 200 plus 12. And if I do that, I get minus 188. Minus 188. So in other words, this number here, T40, term number 40, will be minus 188. And yep, that's really it.